Hi, welcome back to our series, The Uncomfortable Truth About AI Today. This is the episode 2, the $40,000 wake-up call, what running multiple agent AI in production really looks like. Last year, a team launched what seemed like a breakthrough, a network of AI agents built to coordinate market data research. They used frameworks like LangChain and protocols like MCP, the Model Context Protocol. It worked great at first. The bills started coming in, $127, then $891, then $6,240, then $18,400. By the time they pulled the plug, $47,000 gone. What failed? Not just the agents. The missing piece was infrastructure. Let's unpack what really happened and what it tells us about the real cost of multiple agent AI. Let's start with why multi-agent systems are becoming so popular and why they're risky. Modern language models like GPT-4, Claude, or Gemini are generalists. They can handle many tasks, but not all of them at once, and not efficiently. That's where multi-agent systems come in. You split the work between specialized agents. They communicate with each other, agent to agent, and share context through something like the Model Context Protocol. In theory, it's elegant. In practice, the operational layer to manage all this simply doesn't exist yet. The team behind the 40,000K bill said it best. We're building skyscrapers on sand. Even academic research says the same. A paper called Holistic Agent Leaderboard, the missing infrastructure for AI agent evaluation, points out that without real infrastructure, these systems just don't hold up outside the lab. To understand the problem, we need to look at what A2A and MCP actually mean in practice. A2A, or agent-to-agent communication, imagine your agents have their own group chat. They message each other, ask for help, share data, or hand off tasks. Agent A says, "Hey, Agent B, can you pull this data?" Agent B replies with a summary. Agent C combines it all. It's powerful until they start looping. Agent A says, "Did you mean?" Agent B says, "Can you clarify?" And they go into circles for days, literally. Then there is MCP, the Model Context Protocol. Think of MCP as a shared connector, a way for many agents to access the same tools, databases, or logs. And Anthropic announced it to standardize how agents fetch context. It's a smart move. But when multiple agents hit the same MCP endpoint, you get token limits, latency, and cost explosions. From there, the story leads straight into the 7 failure modes that end up costing real money. From the 47K incident and other reports, 7 common failures show up again and again. First, infinite loops. 2 agents stuck talking to each other forever. In those cases, for 11 days. Second, context truncation. Token limits cuts context. User wants to book a flight to Paris on May 15th becomes user wants to book a flight to Third, could be cascade failing. One agent stalls, other depend on it, and the whole chain collapses. Silent failures. Logs say task complete, but the output is empty or wrong. Same for token explosions. Agents reload huge documents instead of catching them, driving up cost and lag. Coordination deadlock. Agents wait on each other with no timeout or fallback. Infrastructure bottlenecks. One MCP server becomes the choke point and everything slows down. These aren't theoretical. They happened. And unless you plan for them, you will pay for them. Literally. So what does product-ready agent infrastructure actually look like? Or rather, what should it look like? In an ideal world, deploying a multi-agent system should be simple. You would push a code, declare agents, connect MCP servers, and instantly see agent health, A2A latency, token usage, real-time cost, and alerts when things break. But in reality, teams are duct taping Redis, queues, wrappers, and half-built dashboards. No loop detection, no-cost governors. The team from the story spent 6 weeks and about 3,500 lines of code just to keep the system stable. Academic papers echo this. Infrastructure and evaluation for agents are still underdeveloped, and experimentation often costs tens of thousands of dollars. Now let's talk about what you can actually do to avoid this $47,000 mistake. Here's what's the data, and the team who learned the hard way suggest. Set cost and token governors, hard daily spend limits, per agent rate limits, token thresholds. Add loop detection, cap how many times agents can talk back and forth, alert on repeat behavior. Cache context, don't reload full documents every time, reuse what's already fetched. Track everything, logs, metrics, message tracking, token counts. Use circuit breakers. If latency spikes or errors rise, slow down or shut off safely. Load test. Simulate traffic before production. Find deadlocks early. Scale horizontally. Don't let one MCP endpoint handle everything. Share and replicate. These are nice to haves. They are survival tools. This matters deeply for builders and startups. If you're building a B2B product with agents, a platform that supports agent workflows, or even consulting around automation, infrastructure is your moat. It's not just about how smart your agents are, it's about whether they can run reliably, affordably, and safely. Most startups today wrap LLMs in the UI. You heard that in our last episode. And call it a product. But when you move into a true agent orchestration, you are in a different game, where a bad design decision can cost tens of thousands overnight. Recent research, like the A12A agent framework, highlights the same point. The hard part isn't the prompt, it's deployment, debugging, and cross-platform coordination. The $47,000 wasn't just a bill, it was a wake-up call. Multi-agent systems, A2A communication, and MCP aren't future theories. They are here, but the infrastructure to run them safely is lagging behind. If you're planning to build with agents, start with infrastructure. Expect to build dashboards, coast guard, and caches. Do not just clever prompts, and budget for stability, not just speed. Because the truth is simple. The builds, the loops, the failures, they are all real. And learning early is a lot cheaper than learning late. So thanks so much. We'll continue our series. And if you have any questions or comments, leave them down in the comment, subscribe, and we appreciate every like on this video. Thank you so much. Bye-bye.